Assalamualaikum and hello everyone. Welcome to this lecture on the circular economy. We will be looking through the lens of chemical engineering. Today, we will explore how we can shift from traditional linear economy mindset to a more sustainable, resource efficient approach. Along the way, we will uncover some exciting applications from solvent recovery to energy efficiency. By the end, you will see how chemical engineers play a critical role in driving this transformation. So, are you ready? Let's go. Let's start with the basic. Think about how we usually interact with resources. Take raw materials, make products, and then we dispose them. That's the linear model, often called take, make, and disposed. But what happens when our resources are limited? Okay, when we rely on non-renewable resources that are running out. It is not just an environmental concern, it is a challenge to our very way of life. For example, consider metal like lithium or cobalt. You know where normally we use lithium and cobalt? It is essential in our battery, in our phones, and electric cars, for example. So these resources are limited. And if we keep discarding them, we will eventually face shortage. Beyond that, the process of extracting, producing, and disposing of these materials create pollutions, depletes ecosystem, and most important thing, also it contributes to climate change. So these linear models also generate mountains of waste, right? All that we are using will be disposed them at once later. So every product we throw away, whether it is broken gadgets or leftover food, often ends up in landfills or incinerators. If it is incinerate, it releases greenhouse gases and harmful chemicals into the environment, added another challenge. So if our world keeps progressing with this model, future generation could face severe resource scarcity, environmental collapse, and rising global temperatures. This is what actually we are experiencing now, in fact, right? We do actually experience rising global temperatures nowadays. So how do we break this cycle? The linear economy cycle, the linear economy model, right? This is where actually the concept of circular economy becomes a game changer, offering solutions that prioritize sustainability and long-term prosperity. So let us explore. What are circular economy? It is a concept that reshaping how we think about our world. Okay, the circular economy is an economy system that changed the way we have been doing for decades. Unlike the traditional take, make, dispose linear model, where resources are used once and then we dispose it, the circular economy is designed to eliminate waste and keep materials in use for as long as possible. Okay, so here's a simple way to think about it. The linear economy is like using a disposable coffee cup, or disposable cup. Okay, once you use it, you will throw it away. While circular economy, on the other hand, is like using a reusable mug. You clean it, you refill it, you use it again and again and again, right? It's smarter, more sustainable, and better for the environment. In terms of cost, at the very beginning, yep, you may say buying a paper cup is cheaper and purchasing a reusable mug is a bit expensive, but thinking of your long term, all right, you can make saving for not only save the money, but you also save the environment. So now let's look at the diagram comparing these two systems. Okay, the linear model starts with resource extraction and then move through productions, and during productions you are going to consume it, use it, and towards the end you will dispose. Okay, it become waste. So notice how it's a straight line. From the raw material, you make something and you throw it after you don't want to use it anymore. So it's a one-way trip for material, often ending up as a waste in a landfill. Well, at the top slides is actually on the circular model. It is a loop. It begins with smart design, okay, ensuring that products can be reused, repaired, or recycled. Okay, materials and resources are recycled back into the system, creating a continuous flow. It's like nature. You just think of how leaves when it falls down from their tree. Okay, so on the soil, okay, they decomposed into nutrients and then fed the soil for new growth. Okay, so meaning that by shifting to a circular economy, we can reduce waste, conserve resources, and regenerate natural system. So as we go through today, all right, today's lecture, think about how this concept can be applied in your daily life, your daily activities to create more sustainable future. Okay, let us break the concept into three simple yet powerful principles, okay, that can change how we interact with the world. Okay, first is design out waste and pollution. Imagine if every product, like the packaging for your favorite snacks, for example, okay, that the pack itself is designed to biodegrade harmlessly into the environment, okay, not producing the microplastic but biodegrade and become fertilizer, you will definitely feel good, right? And for chemical engineers, this principle, okay, design out waste. You don't want, you starting from design is actually you remove the waste and pollution part. So the principle is designing processes that minimize byproducts and emissions. Think about using green chemistry techniques to eliminate hazardous waste during productions. How can we create systems that are cleaner right from the beginning? Okay, so the second principle is keep materials or product in use. How many of you have an old smartphone sitting in a drawer, in your drawer now? Okay, what if instead of letting it gather dust, the metal inside, we recycle to make new gadgets? Or better yet, the phones was refurbished and reused by someone else. That also another option. So this principle is about giving materials a second, third, or even limited lifespan. Okay, So for chemical engineers, this principle, okay, the principle of key materials in use, translate into innovation like solvent recovery system in industrial processes. Instead of discarding used solvent, we purify and reuse them. It's all about finding ways to loop materials back into the system instead of discard them after one time use only. Okay? Next principle is regenerate natural system. How is it? Okay, think of the food scrap left on your plate after dinner, after lunch maybe. So instead of throwing them into the trash, imagine turning them into rich compost that helps farmers grow healthier crops. It is not just about recycling, but giving back to nature in ways that makes it thrive. Okay, so maybe you can start initiate something in your cafe now. Okay, so for chemical engineers, this principle, okay, regenerate natural system, the principle might involve designing system to turn industrial organic waste into biogas or biofertilizer. Right, so look at the system, look at the company, what waste they are producing. So basically, which waste that can be actually regenerate. It's about creating solutions that don't just reduce harm but actively restore and support the environment. So now, how could you apply this principle to your hostel, for example? And as a future engineers, you need to have this kind of mind. Okay, when you enter the industry, you are thinking about how to make benefits to your company as well as to the society. Okay, so start thinking about how this principle can inspire sustainable innovation in your future career. Right, so as a chemical engineer, we play an important role in making the circular economy a reality. So this the one that you are seeing now is actually a simple diagram of industry, okay, ammonia productions industry. So this is just an example. You will definitely have a different process flow diagram, okay, because remember, in as a chemical engineer, our work goes beyond theories. Okay, we create practical solutions that bridge sustainability with industry. Okay, from designing processes to recycle material, you optimize how resources are used and creating energy efficient system. Chemical engineers are at the core of this transformation. Okay, you are the one responsible. So now take a closer look to the diagram on the slides. Okay, so it highlights how chemical engineering connects to key aspect of the circular economy. Okay, each of these processes you can see steam reforming, partial oxidation, shift conversion, gas refining, and ammonia synthesis. All right, so these are the part and parcel of these ammonia productions. Okay, they play a significant role in chemical industry, and rethink of them through the lens of a circular economy. All right, how to create opportunities for waste production, resource efficiency. Okay, so you want to reduce the waste from this plant, okay, and you make sure that the resource is efficient enough and overall production is sustainable. All right, so by innovating within this area, chemical engineers can turn traditional linear processes into closed loop system, contribution to a greener and more sustainable industrial future. Okay, So this is just an example, and I'll give you a detailed industrial application. So this example for solvent recovery system. Okay, let us see into a practical example. Okay, solvent are always the backbone of many industries, from pharmaceutical to petrochemicals. Okay, because solvent play a critical role in extracting and purifying chemicals. Okay, throughout your subjects later, you will identify that different types of solvents, and these solvents commonly being used in many industry. However, this solvent is not cheap. Okay, they are expensive to produce, but another disadvantage is they are hazardous to be disposed. This is what you've learned in your lecture before, law. All right, so instead of treating used solvent as waste, why not we recover and reuse them? Okay, so from these slides, basically you can see DMF, okay, a solvent which is widely used in making synthetic leather and acrylic fiber. Okay, by recovering and purifying it through methods like distillations and membrane separation, industries can significantly cut costs, okay, while reducing environmental harm. Okay, imagine the collective impact if every chemical plant's able to recover. The boss must love you so much. Okay, so you lower waste disposal. You don't need to send to the quality alarm and whatnot. Okay, you reduce pollutions, and definitely you will make a cost saving to the company. Okay, so for this plan, basically what I want to show you here is basically let us see on the input stream. All right, input stream, solvent are introduced into a system to extract or purify specific chemicals. This is a use. Okay, the used solvent, the new solvent coming in, and the purified solvent is also coming in. All right, so that is the input stream. And the recovery process, okay, so the recovery process in the blue DMF DMAC recovery system over there is after used. Okay, after you have actually gone through all the processes in the plant. All right, so basically the spent solvent are treated using techniques such as you can use distillation, filtration, or membrane separation to remove all the impurities from the solvent. And now the solvent is free from impurities. You can take it back. Okay, you can take it back to the what we call that, purified. Okay, from this line into the inlet tank again. All right, so this is part after you have actually purified the system using this recovery system. So you have to install one recovery system in the plant, because all this while the plant is only having input and they are processing. So after process, what happened? They dispose. They don't have the dotted part here. Okay, so in circular economy, you will introduce a recovery system in your plant. That's why I said the cost might be increased, okay, because there will be a new equipment have to be installed, but later we'll talk about this part as well. So the final one is on the output quality. All right, for the output quality, you have to ensure that the purified solvent are reintegrated into the process, okay, and the quality of the purified used solvent is also par level to the virgin DMF, okay, virgin solvent. So this approach, I might tell you, it is not theory. It's not for theoretical knowledge. No, industry worldwide, they are already adopting this solvent recovery system, okay, to enhance sustainability. Sometimes it's not meant for sustainability, but they want to save costs. Okay, but that's the beauty. You save costs, at the same time the company able to enhance their sustainability and comply to environmental regulation. Okay, all right. So these are the things that can be made from recovery system. Okay, let us see into another industrial application, steam condensate and recovery process. Okay, so steam basically is a classic example of energy we often waste. Okay, once it become a steam, after you heat certain products, okay, then the steam is just wasted. But in circular economic, you can actually condensate it and become the feed for the boiler. So the boiler doesn't need new water to actually operate. Okay, so by capturing and reusing this energy, we can dramatically improve efficiency. So imagine a factory installing a condensate. Okay, you have a condensate in your company, and instead of letting the condensate go down the drain, it's pumping back to the boiler to become steam again. So this will save fuel, you save water, and of course you save money. So while reducing greenhouse gas emission, this is a win-win situation. Okay, all right. Implementation strategy. Here we will be talking about how to make this system work. Okay, because successful system involve in few key strategies. Okay, the first one, what we want to see. Okay, because we want to have the circular economy implemented in our company, we will see, do we need to have install a new equipment. So the first one is on equipment requirement. Okay, so adding a system like heat exchanger, okay, and the one that I showed you earlier in solvent recovery system, that are equipment that is required to be installed in a company. Okay, instead of producing the product, but that is another equipment to be installed. So the challenge is integrating this equipment into existing setup without causing major disruption. Okay, so modular design can help ease of this process. So engineers, those will be in designing design engineers later, especially for chemical plants, think about this. Okay, if in the future there are possibility to install another equipment in your plant, so you already know the setup area. Okay, this you will learn in your final year. The second is on process modification. So adjusting to conditions like temperature and pressure can optimize efficiency. However, these changes might affect the productions or require staff to be trained. So engineers can use simulations to ensure these modifications are practical and effective. Okay, the third one is quality control, right? So recovered material, just now you purify the solvent, so the material or the solvent must meet performance standards to ensure safety and reliability for the plant. Okay, regular testing, monitoring are essential to maintain consistency throughout the productions of recycled material. Okay, recycle energy and whatnot. Okay, so the challenge, okay, it is not come very easy. Okay, if you plan to implement some circular economic in terms of having an equipment in a plant, there are challenges. Okay, company might face high cost or technical limitations. There might not be some expert on this area, but what happened is engineers can address this by designing cost-effective solution and streamlining processes. If require experts in specific field, you may hire an expert. Until the expert train the local people, then basically the term is actually an advantage for you already. Okay, now the critical part where the bosses will ask you, okay, before you have actually proposed to the company, but before you start with the project, okay, in your proposal, you need to ask, is it worth the investment? Does it make financial sense? Okay, all right. So to answer your boss, normally engineers, let us break this into 4 key factors. The first one is investment cost, okay, because this is the upfront expenses for equipment, installation and setup. Okay, whatever new equipment will be actually installed in your company for recovery and whatsoever. So the equipment cost is one, installation cost is another one, and setup of places and everything is another part to be considered. So that falls under investment cost. And normally it is the biggest hurdles, okay, that you need to really convince the management that you will definitely have a long-term gain. All right, so investment cost done, go into operational cost. Okay, the operating cost, it is actually the ongoing expenses, okay, while your equipment that you have already installed, throughout its operation, it requires some maintenance, okay, labor working on that processes, and materials to be used. All right, so all this falls under operating costs, and that keeps the system running efficiently, and all these costs you need to also count it. Okay, third one is the payback period. Okay, payback period tells us how long it takes to recover the initial investment. For example, initial investment that you are actually required to install an equipment, for example, 100K. Okay, but through this 100,000 of investment, within 5 years, within 4 years, okay, for example, you are saving 25K a year by the operations of your recycling system. So basically 25 years, 25K, you times 4 years, so basically you get back your 100K of your initial investment cost. So that means your payback period is only 4 years. Okay, so after the 4 years, you are gaining back the benefits. All right, so return on investment is the fourth one. Okay, ROI shows the total financial benefits over the project lifespan, meaning that higher ROI giving you a strong financial benefits in a long-term run. Okay, so take an example of a solar panel. Okay, the upfront cost may seem high, but energy saving over 20 years. Okay, for example, that solar panel can only work within 20 years, the lifespan. So within that 20 years, you make a smart investment by a lot more saving compared to your initial investment. Right? So this is an advantage. So now think about this, and what are other sustainable technologies offer similar economic benefits? Okay, so once you are in a company, you will start thinking of what are the things that you can actually make a saving for your company. All right, Now we will be going into the environmental benefit. Okay, before we wrap up, talking about the environmental rewards. Okay, when we reuse resources and conserve energy, we significantly reduce waste, we save water, we cut greenhouse gas emission, right? You feel good. It's like giving resources a second life, turning what we once considered waste into something valuable, right? On waste reduction. Take food, for example. Okay, instead of sending it to landfill, okay, everything rotten at the landfill, giving bad odor and whatnot, so where it produce harmful and methane emissions some more, okay, you can convert it into biogas, a clean energy source. This not only reduces waste but also provides a renewable energy. I'll share with you a story later. Okay, now think about industry. What if industry reuse waste heat to power other processes? Okay, all right. So the benefits for environment, as I mentioned earlier, on waste reduction, you can have the energy saving. Okay, capture certain energy and reuse back the energy. So basically, the company's fuel consumption will be actually reduced. Okay, your operating cost will be lower, and carbon footprint also will be reduced, okay, from your operations of the company when you implement this economic cycle economy cycle. All right, but now I'm going to share, okay, an inspiring example from Perak. Okay, from Perak, the very close to us, basically in Malaysia. The example is specifically at Felda Besaut Palm Oil Mill. Anybody from Felda? Or to be specific, anybody from Felda Besaut here? Okay, so this mill, for your information, if you don't know, either Malaysia already practices the circular economy or not, so I'm telling you now about a story of Felda Besaut Palm Oil Mill. Okay, this mill has taken a big step towards sustainability by converting its palm oil mill effluent, the wastewater that coming out from their plant, okay, from their operating plants, boom, okay, into energy. How it works? Okay, palm, which is a liquid waste from processing palm oil, naturally releases methane. Okay, this is a greenhouse gases, and instead of letting this gas escape into atmosphere, okay, this mill capture the methane gas and use it to produce biogas. Okay, so basically it is in a column, a big column. Okay, all the effluent will be installed in that column, and upon the productions of methane, okay, with the helps of your microbes, as you learn in the wastewater treatment plant, okay, so the methane is actually produced, and this biogas is then converted into electricity. So this electricity is not just for the mill to use it for their operation, but what happened is this mill also supply energy to the surrounding community for free. Okay, so those are living or reside near to this Felda Besaut, normally they have a free electricity. Okay, so what even more impressive about this approach is basically the system has been in place since 2015, making it a pioneer in integrating waste to energy practices in Malaysia. Interesting, right? Okay, so engineers, this is a challenge for you. Think about it. Not only does the reduced greenhouse gases emission, but it also cut down the energy costs and provides free electricity to the neighborhood. Okay, so what if other industries replicates the same concept as Felda Basau done? Okay, maybe here we are in USM also able to get a free electricity from our neighbor, okay, the palm oil mill as well. Okay, the same thing. It's just that when they have a different approach of treating their waste, so the waste become waste. It is not becoming a benefit to surrounding societies. All right. So now imagine if industries adopted this. Okay. It's powerful to see how this innovation can create a win-win situation for everyone involved. Okay. Get it? Okay, so now it's your turn. Think about a process of material related to your field of interest. Okay, the assignment is about circular economic infographic. Okay, you need to work in a team of 4, and one person can only work in one team only. Okay, no replications, no delay in submissions. I will not entertain any delay submission. All right, so you could actually use the principle of the circular economic, design out waste, keeping materials in use, or regenerating system to make it more informations in your infographic. Okay, make this opportunity to study more on circular economic, think creatively, all right, and propose one industry. This is the most important thing in this assignment is I want you to propose one industry process that could align with circular economic principle. Okay, so the rubric is given and the submission detail is here. Okay, you can provide me in a PDF form or in any high quality image. All right, the deadline is on 17th of January 2025 at 11:59 p.m. Okay, bye then. See you in the next class. Assalamualaikum.